Hey, Matthew.
Hey Jack, what would you like to work on today?
All right, I'm going to send you a worksheet.
Okay.
There we go. Let's just send right about now. There we go. This is a little bit of 10.2 Law of Cosines, and she just wants us to do the odd ones. So it should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
All right. Teachers just grabbing stuff off the internet.
Yep.
All right. Law of cosines. All right. So you first need to know when to use law of cosines. I know it just says to do it in this problem, but more generally, there's a couple of cases when you use law of cosines. The first is when you're given a side, angle, side, angle, side, like we've got here. Second case is when you're given three sides, side.
Yeah.
You will eventually get to problems where you have to just solve the triangle and you don't have to, it just, how do I want to say this? You have to know which one to use. So
Okay.
the law of cosines comes in three flavors. I'm going to write out the Pythagorean theorem though to do this. So c squared equals a squared plus b squared minus 2ab cosine big C.
You're not presenting, by the way.
Oh, thank you for letting me know. I'm so sorry.
That's so fun. Uh,
It'll make a lot more sense when you see my screen. The things
yeah.
I'm writing down here. Okay, screen is being shared. I've got the picture in side, angle, side. I wrote down over here law of cosines. You're doing side, angle, side, or side. Now there's three law of cosines formulas, and then there's even six if you solve it for the angle. I generally just do it this way, and I'm going to try to explain this in as much detail as I can. So A and B and C, this is the side, this is the angle between them, and this is the side. So like in this problem, this is A, this is B, and this is big C.
Yeah.
So we're solving for TR or RT, that's over here. So it's kind of a weird mapping. If you're not comfortable with the variables being different, you got to get comfortable. Otherwise, they're too hard to do trying to rewrite the formulas for the letters you got there. So in your case, you've got 23 squared plus 15 squared minus 2 times 23 times 15 cosine of 27 degrees. And then to get C, you take the square root of that.
Oh, okay.
So what most students do is they get this number and then they take the square root of that number.
Hmm. Is that not correct?
No, that is. I mean, that's what most students do. They do it in two steps. Your calculator can do it all in one step.
I was kind of sensing a butt there, and I was kind of.
Yeah, I was thinking about it, but I'm uh, hold off on some of those things for now. So 11.8 is what the answer key says.
Hmm.
Hopefully you get that.
Let me figure. I'm gonna put it all together. Try to see if my calculator can handle this. 27. Dude, I got 139 at first. Once I add everything up, I'll put into the square root, and I get 11.79. All right, perfect.
Okay, so that's number one, and you said we're gonna do number uh,
Three.
three.
We're
Three,
gonna go
just
with all these just through odd. It should be 11 problems total.
okay. Got it. I can
You,
remember that.
do you think that you could help me with a little bit of microeconomics?
I can. Some of it is
Beyond you?
no. At the college level, it's clear because it's done through McGraw Hill, and it's easier to explain. Depending on what you have, I may or may not be able to give you what you want out of it. But
Mm-hmm.
we're finding DE. DE is across from the angle. So I'm gonna call 26A, 10B, and this big angle C. So
Okay.
this little c is what we're trying to find. Little c squared equals a squared plus b squared. This is the Pythagorean theorem. Minus 2, it's always these two letters repeated, ab
Let's see.
cosine big C.
Oh, okay. So what we have here is we're gonna set it up as all right.
So I'm just substituting the numbers in.
Yeah. All right. 26 squared plus 10 squared minus 2 times 26 times 10 cosine 48. All right.
Yep. So when you do all that, you get, I'm just scrolling down the answer key, you end up getting that C equals 20.7.
27? Okay, 20.7.
20.7.
All right, on the number 5.
On to number 5. So this is another side angle side. After this one, it moves to the other case, which is side, side, side.
Oh, okay.
So
this
again,
is kind of applying a bunch of geometry themes with trigonometry.
this is trigonometry. It's non-right triangle trigonometry.
Oh, okay.
So we're trying to find C again. Well, actually, no, I take that back. We're trying to find angle A. So to find angle A, we need to know side C. Because this, well, let me just have you find side C, and then we'll talk about why you need that to find angle A.
Squared plus 15 squared, and then we square the. I get like 17.5.
For C.
Yeah.
Let's go with that. I can check it if it's critical.
Well, just by doing Pythagorean Theorem, that's what I did.
Oh no.
No. I just did that. Just I don't know why.
You got to use law of cosines here. It's not a right triangle. It's not a right triangle. So that's why you have to use law of cosines.
All right. Very slow person moment for me.
Okay. So yeah, get this value of C, and then we'll talk about.
All right. 19 squared plus 15 squared. All right, minus 2 times 9 times 15, then cosine 107. All right, so you get that big number squared out. I get 19.61.
Okay, let's go with that. Now, if I draw the triangle again, 19.61, 107 degrees. Do you see I have a side and an angle across from the side?
Mm-hmm.
We want to find angle A, and you've got the side across from the angle.
Okay.
So now you're going to use law of sines. You could use law of cosines, but it's not necessary. You only use law of cosines one time in any given triangle problem.
Otherwise, it's just extra work.
Yeah, you would never do it. But your instructor knows this. They're not emphasizing this. So to find A, which is the sine of A, it's over 9.
Okay.
Because it's always the sine over the side equals the sine of 107 degrees over the side you just found, 19.61. Now we didn't go beyond this in your worksheet from last night. To solve for sine A, you multiply both sides by 9. So it's 9 sine 107 over 19.61. So that gives you what sine of A is, but you have to solve for A. You have to be able to undo sine. So to undo sine, you do that with sine inverse.
Oh, okay.
So 9 sine 107. 9 sine 107 over 19.61. So that all goes in your calculator. If you do that correctly, according to this, the angle is 26 degrees. But it's also contingent on you having found that other side correctly. So give that a look. Give that a calculation. See if you get 26 degrees.
twice exponent of 3.
Close enough. Okay.
All right, on to number 7.
Yeah, so I'm actually very surprised they gave you 5 because usually this worksheet just emphasizes using law of cosines.
Yeah.
Number 7 is law of cosines, but you're using it to find the angle this time. So this is the first time we're using the formula to find the angle. Notice how you're given all 3 sides. So
Yeah.
they want you to find R. So just to stay with the convention, we're going to call that big C, because it's better to just have one formula. So that's little c, and these don't matter. That can be little a and little b. Great. So little c squared equals a squared plus b squared minus 2ab cosine big C. So I've written the same formula. This again, like there's only one formula you need to know. I know they give you 3 plus another 3, but that you just need one formula here.
Okay.
You're trying to get to cosine C.
Yes.
So you fill in all these other numbers. 28 squared equals 18 squared plus 12 squared minus 2 times 18 times 12 cosine big C. So this is where most students make a lot of mistakes. You are trying to isolate the cosine C, which means you have to undo this. You have to subtract 18 squared, subtract 12 squared, then divide by -2 times 18 times 12, whatever that is, you divide by it. So here, let me just show you what this looks like. It's 28 squared minus 18 squared minus 12 squared divided by -2 times 18 times 12. You're a good enough student that you should be able to enter all of that into your calculator, get a number, and tell me what that equals in regards to cosine C. You should be able to get this number on the left, and then the last step is to take the arc cosine of both sides.
18 squared plus 12 squared. There we got that. And divide that by -2 times 18 times 12. -0.73.
Okay, so take the arc cosine of that.
Oh, yeah, because you gotta undo it.
That's right.
I get 137.
And that's it. Ding, ding. So C is equal to that. Now, if you want to be that all-star student here, you could actually just do the cosine inverse of all of this that you just, you could just grab that, paste that here. You could actually just do all that in one step here if you want. Up to you. Okay, move on to 9.
Yes.
I'm sorry, you just reminded me. And how far past 11 do we need to go?
Just all the way down to 21.
Just all the way down. The next ones are they make you find everything in the triangle, so it's a lot longer problem. Okay, 9 says to find the measure of angle E. E is over here. You cannot use law of cosines to find angle E.
Yeah.
The only thing you can use law of cosines to find is this side length over here. Once you have this side length, you'll have an angle side pair, and you'll have a side angle that you're trying to find. So the steps here is you're going to use law of cosines to find FE, this right up here, and then you're going to use law of sines to find angle E. So rather than calling this D, I'm going to call this big C. This is little c, this is A, and this is B.
Okay.
So it's the same equation. C squared equals A squared plus B squared minus 2AB cosine big C. 20 squared plus 30 squared minus 2 times 20 times 30.
Is it 20 squared plus 30 squared?
Yeah, 20 squared plus 30 squared.
2 times 20 times 30. Cosine 59. Oh, we go up to 13 and then switch over to the other homework.
Okay. What did you get here for C?
For C. I'm still putting that in.
Okay, yeah.
20 squared. It's 20 times 30 cosine 59. Alright, so square root that. And I get 26.1.
Okay, so 26.1, we'll call it. So
Uh-huh.
we have this side, we have the angle across from it. We're trying to find this angle and we have the side across from it. So that's a law of sines.
Yeah.
I always put the thing that we're trying to find in the top left. That's my convention. I think it's much better than just sort of putting it wherever. Since the angle's on top, the side has to be on the bottom. That's 20 over sine 59 over 26.1. So I am breaking my convention of telling you to use the known information. You have to calculate 26.1 correctly, or this problem goes nowhere because you'll propagate the wrong answer throughout the rest of the problem. Sine E, you can solve for this by multiplying both sides by 20. So it's 20 over 26.1 sine 59. And again, if you want to be that all-star, superstar student here, you would take the sine inverse of 20 over 26.1 sine 59. You can do that all on your calculator and get the result right away from it.
All right, look at that.
It's about 41 degrees according to the answer key.
And you get, all right. All right. Number 11.
Number 11. So now this is kind of the exam question. This is the, all right, we're going to give you a triangle. We're going to tell you to solve the triangle. That means they want all the angles and all the sides. Now you're given all the sides, so that's a good start here. You need to find an angle. That's the only direction you can go. So the first thing you're going to do here is you're going to use law of cosines to find an angle. After you find an angle, doesn't matter which one we find, you're not going to use law of cosines. You're going to use law of sines to find another angle. So let's just say we find x and then we find y. To find z, you're going to use the fact that x plus y plus z equals 180. Or more generally, because I don't even like writing this, the sum of the angles is 180.
Okay.
So just more generally here, since I'm writing it out, at most you will use law of sines 2 times. That's the absolute worst case scenario, is you use it 2 times. You never use law of cosines more than once, because this law of sines is way easier. Okay, to do this problem, I'm just going to arbitrarily choose x to be angle C. The side across from it is little c, and then I'm just going to call that A and B. Just, it doesn't matter. I made it up. I do it this way. So c squared equals a squared plus b squared minus 2ab cosine big C. You have to get comfortable with the formula. You'll probably have to remember it for an exam. 2 times 25 times 28 cosine big C. You're trying to isolate cosine C. So to do that, you're moving these squared terms over. It's 27 squared minus 25 squared minus 28 squared, all in parentheses, all in the numerator, divided by -2 times 25 times 28 in parentheses. So you get that number. That's not your angle. You have to use the arc cosine to find that angle. So give me that value. Should be around 60-ish, plus or minus 5 to 10 for this particular triangle.
I get 0.485.
Okay, so take the cosine inverse of that.
Cosine inverse. All right. 60.94.
So 60.9 degrees.
Mm-hmm.
Okay. All right, so now we're going to use the law of sines.
All right.
So we get to decide. I'm just going to arbitrarily pick y. It doesn't matter since we got all three sides. So to find y, to find the sine of y, we need the side across from it. That's 25 equals the sine of 60.9. The side across from it is 27. So that's your law of sines there. So the sine of y is equal to 25 over 27. I'm just moving the 25 sine 60.9. So y is equal to the sine inverse, or arc sine, 25 over 27 sine 60.9.
All right.
And that should be, again, pretty close to 60. The reason I know that and can tell is because all the side lengths are about the same, which means it's close to an equilateral triangle. There's not some magic that I know about these.
$54.0.
It's about 54 degrees. Now you've got two of the three angles, so you don't need to do anything else. The law of cosines, law of sines, you just need to add them up and subtract from 180. Looks like it's going to be like 65.1 maybe.
That's it.
Okay.
All right. All right. Can we switch to the other homework for micro?
Yes. Before we do that, though, let me just briefly tell you that for 19, you have to use a special formula for that. Let me just at least write the formula down for it. So you've got it. The formula is no. Okay, so there's actually two formulas. I thought for the law of cosines, if you give you a side angle side, so that notice how you don't have I don't know what they're doing here. You're going to use law of sines to find P, angle P. Once you have angle P, the formula for area is 1/2 AB sine C. And that's because you've got the side angle side, that it'll become 1/2 7 times 11 times the sine of angle P when you get that there. That might have not been helpful, but yeah, go ahead and send over the macro homework, and
Should be in your email.
should be there. Okay, open in docs. See what you got. All right. Okay. Yeah, we can do this.
Perfect.
All right. If lunch today sells for $10, what is the value of Giselle's consumer surplus? So it's kind of, there's actually there's really two parts to this question. There's this line here at $10 where Raina, Anthony, and Jack don't. Well, sorry, I shouldn't have said. I thought there's in order. If lunch sells for $10 and you're only willing to pay 7 or 8, you're not going to buy lunch.
Yeah.
Okay, so that's the first thing here. Because lunch is fixed amount, the consumer surplus, which you can put here, it's 20 minus 10, which is 10. 15 minus 10, which is 5. This one, it's not applicable. 12 minus 10, which is 2.
And not applicable for Jack.
So Giselle's consumer surplus is $5.
$5.
Now, if lunch today sells for $9, what is the total value of the consumer surplus? So we have to redo this calculation for $9. So you've got 20 minus 9, that's 11. 15 minus 9, that's 6. This one's not applicable. 12 minus 9 is 3. And the last one is not applicable. So the total consumer surplus is you add up the ones.
11 plus 6 plus 3.
Yeah, which is $20.
$20. All right. Decent enough.
Yep. If lunch today sells for $11, who will not purchase? So basically they're asking the question we already covered, which is like, who doesn't have $11 that they're willing to spend here? Or who's below that? So the answer is Raina at $8. She's below it. And Jack, some other Jack at $7. Now, this is something you might want to ask your instructor is what happens when price equals consumer surplus? Like, let's say Matthew only has $11. What would he do? I don't actually know the answer to that. So that might get you some extra points with your instructor if you ask something like that. Is that okay? That part?
Yes.
Okay.
Well, was when price equals consumer surplus. Oh, that's interesting.
Or I'm sorry, not when price equals price willing to pay. Price equals sells. I guess is what we're asking.
Okay.
I believe they'll still buy, but I don't know for sure. Just as sort of an aside, economics is based on rational choice theory. And what that means is like you made a decision to do something rational, reasonable. I'm not sure that's true. Like I don't know that people actually operate that way anymore, but that's just an aside. So, okay, we got a competitive market here. 1,000 units are sold at $20 per unit. So we got two axes here. What goes on the bottom axis? What goes on the top axis? You remember price and quantity?
I think so. Yeah.
What? So that I'm asking you. Price goes here.
Yeah.
And quantity goes here. So a tax. So we know that like there's a something goes down here and something goes down here, and we know that the quantity here is 1,000, and the price is 20.
Okay.
Is that okay?
That's correct. Yes.
All right. A tax is imposed of $4 per unit, and the new consumer price is now $23. So there's $23 here, and the new equilibrium quantity is. I guess they're telling you that this is 950. What is the tax revenue collected and the deadweight loss? Okay. Have you seen this before in class?
Yes.
Okay, so there's generally, when you have one of these graphs, they call it a tax wedge that's created, and the deadweight loss is here.
Yeah.
And the tax revenue is here, I believe.
Okay.
Let me just double check that.
Wait, so what does deadweight loss mean?
Well, I don't have this is where I struggle to give you the sort of the correct answer to that. Like my understanding is that it's the part that doesn't go to tax that is taken away from consumer and producer surplus.
Oh.
And I think you need more information. So in a perfect world, which we're going to leave at 11, but a perfect world, here's consumer surplus, here's producer surplus.
Yeah.
Well, when you put this tax, they call it a wedge. I don't really get it, but they call it a wedge. And not all the money is going to tax. Like it's not like you create this tax and then you get everything. You miss out on this little triangle part. And that's what's referred to as this deadweight loss, this part that doesn't go anywhere.
Oh.
So the tax is imposed for the governments to collect money, the consumers lose, the producers lose, and there's this deadweight loss. So you might ask yourself, why do we impose taxes? It's different class, different
Macroeconomics, right?
Well, I was going to say that's more of your government class.
Oh.
Okay, so nevertheless here, the tax revenue that's collected, my understanding here is that we're trying to just find the areas of these rectangles. Now, sadly, I'm not that confident in my work here. I definitely want to check this with an online resource and see if we're moving down the right road. I think we are, but well, they just give the answer in this first resource, which is not helpful. Do you have the solutions to this?
I don't have them with me now.
Okay. Okay, so let me find. They have the same question with the same number. So let me just figure out how they got the answers. So the tax revenue, let me just do a quick calculation here before I say anything. Okay, so the taxes imposed is $4 per unit. Since we know the new price is 23, that $4 has to be this width, this height here. So that means this is 19, because 23 minus 19 equals 4. So that 19 is what we didn't know. We didn't know the
Oh, there's a 19 there?
yeah, because it was 23. I'm sorry, it was 20 and it went up to 23, but there was a $4 per unit increase. And what's not clear is that $4 per unit increase, some of it is absorbed by the consumers and the producers.
Oh.
So we know that $3 is from the consumer side, because it tells us that 23 is up here. 23 is up on the consumer side, which is up above this. The 19 is down here, because this has got to be a $4 width. So the tax revenue is this rectangle here.
Yeah, of course.
And finding that is very simple. Once you have the numbers, it's base times height. It's 950 times 4.
Tax equals 950 times 4.
Yes.
Wait, so how's that 950 times 4? Because you add all those up together, or what do you do again?
$4. Oh, no. $4. Yeah. It's
okay.
Not to scale. So
by the tax wizard.
There really should be build-up problems to this where they do these calculations and you just read from the graph, finding these things. But
unfortunate.
Yeah. Okay. Next thing here is.
That's the total. Is that the total tax revenue, or what kind of tax?
That's the tax revenue. The
tax. Straight up tax revenue.
That's tax. Right. Yeah, that goes in here. The DWL, deadweight loss, is this triangle here.
Okay.
So to find the area of the triangle, it's the height. The height is 1,000 minus 950, which is 50. And then this right here is the 23 minus the 19. That's the 4. So the DWL is 4 times 50, or 200.
Right, so 1,000 minus 950, you got 50, and you multiply it by that 4.
Okay. Yeah, 23 minus yeah.
So that deadweight loss is at $200. Okay. Thank you. You make this very simple, very understandable.
Well, you gave me something I actually know quite a bit about in economics. So
yeah.
Okay, so 5 we should have done first, because it kind of steps through these things much more clearly.
Okay.
But nevertheless, we will. So I may have to paste this picture in a couple of times. I'm gonna ask you to refer to the questions here. I don't have to rewrite them. Well, actually, I'm gonna take that back. So what is the consumer surplus before the tax? So what is not? There's too much stuff going on. This is the equilibrium price before the tax. So the
Hey, which
consumer,
one? Which one's equal?
I just
20.
just
Okay.
did a dot there, and then I'm drawing. This is all for part A. I'll just probably redraw the. I'll probably copy in the picture for each one again. That'll be the best way to learn.
Okay.
So you're just finding the consumer surplus is the area of this triangle. It's 1/2 the base. The base is 20. That's the quantity.
Mhm.
The height is 40 minus 25. That's your height. Base times height.
Okay.
So whatever that is, 10 times 15, that's 150, usually in dollars.
No, I got what's price surplus? What is
Here's
that?
producer surplus.
Producer
So
surplus.
part B
Okay.
is producer surplus. You go to the equilibrium quantity before the tax, and it's this triangle down here. It's bounded. Here's the thing. It's not always a triangle. Like it's curves, but they don't tell you that. If you take business calculus in college, you'll see this again. But it's just this bottom part. So it's 1/2. Your base is 20 again.
Yeah.
Your height this time is 25 minus 5.
Okay. So you get 20 times 20, 400, 200. Should have 200, right?
Yeah, 200.
All right. What is the total welfare surplus before the tax? What's total welfare mean?
Which means consumer surplus plus producer surplus.
Oh, okay.
So
So the
part
whole
C,
rectangle right there?
that it's a big triangle.
Oh, that one? Okay.
Yeah, let me draw it in here because I think it'll make more sense. This 3. So 3 is this big triangle. There's 2 ways to calculate it. It's either producer surplus plus consumer surplus, or you can go 1/2 base and your height is 40 minus 5.
4 minus 5. Okay.
All right, what's next here?
Should be number 4. What is the per unit tax?
What is the okay? So they're basically asking like, what happened here? Like your tax is now here. What happened? Well, what happened is it went up from being 25 to now 27. That's your new price.
Oh, okay.
But well, what's not clear? It's not clear is. Sorry, I gotta look at this in a little more detail. I guess I just want to say that the tax is the amount that it went up. So your price was 25, and your price now is 27. So I want to say it's a $2 tax.
$2 tax. Okay. $2 tax. Okay. What's the consumer surplus after the tax? Label that area A.
So let me copy the picture in again, and then that will help here to answer this. So here's your new point. So the consumer surplus is this area right here.
Mhm.
Hang on just a second, please. All right, I'm back here. So it's just this upper triangle is the new one, is the producer surplus.
All right. So, wait, is it the triangle thing?
Yeah,
One
it's
half based on
one
height?
half, but it's 15 this time, and then your height is 40 minus 27.
Okay. So 40 minus 27, it's like 13 times 15. Oh, wait. Yeah, 13 times 15 divided by 2. Divided by 2. 97.5.
Yeah, that sounds reasonable.
All right.
So I had to draw it on this one because I think it's easier to show, but the tax is there, and then the consumer surplus is here,
Yeah.
and this is the DWL.
Okay.
So the how much of the tax is paid by consumers? It looks. I'm sorry. Are we up to 6? No, we're up to 6. Yeah.
Yeah.
So 6 is calculate the amount of tax revenue. So I think the tax revenue. This is where I'm a little bit unsure because I could be leading you down the wrong road here. Let me check my resource here. Okay, not 100% sure on this. So the tax, though, I believe is going to be this rectangle here. So it's going to be the base 15 times the height 27 minus 21. But that would
Okay.
that would lead you to think. So the problem is this would lead you to think it's a $6 tax.
Yeah.
And it could be a $6 tax, but that means that $2 is paid by the well, I have this completely wrong, consumers, and then $4 is paid by the producers.
Oh, okay.
So I'm a little unsure on that, but I'm pretty sure this is correct. I think it's $90 for this. But we may want to change our answer to this to be, well, it is 27, but it's the tax is really 27 minus 21. I want to say it's a $6.
All right. So now we go down to how much of the tax is paid by the consumer, and the consumer is the 25 to 21 rectangle, right?
The consumer is the top one, the 27 to 25.
Okay,
Consumers on top. I miswrote that
Okay.
at some point.
So $2 times 15, 30, yeah, $30 should be right.
Yes, that sounds reasonable. Yeah, it's going to be, this is the consumer side.
$30 for this. Right.
Yeah, it's 15 times 27 minus 25. And the producer side is 15 times 25 minus 21, which is 60.
460. All right.
How much is the total expenditures after the tax? I don't actually know what they're referring to there. I actually have no idea what they're referring to there. So we can, maybe they're asking, yeah, I don't, maybe they're asking for the quantity. I actually don't know what they're asking for. 9 total expenditures. I'm not sure. The producer, though, and this is where the producer is going to get a lot less. They're getting this triangle down here. Maybe they're asking for 9, the new consumer surplus plus the new producer surplus.
Mhm.
I wish I could be sure. but 10 is definitely asking for the, oh no, that is what they're asking for in 9. That is what they're
Oh.
asking for in 9. Okay, I can say that for sure, because revenue is much more straightforward. It's price times quantity, and the producers are getting $21 times $15.
Okay.
That doesn't seem right either. Sorry, I'm not as effective here. I don't really know what. Yeah. Probably a quick email to your instructor could analyze this, or sometimes you can just do a search for like total expenditures after taxes, and then look for a graph. Usually the graph is better for this. Not seeing anything. Seeing a lot of non-economic things. Okay. Is that the last question on this? Yeah.
Yes.
All right. Well, start out strong, didn't end strong. See, the revenue could be this thing down here, this triangle, and that's what I'm not sure of. Maybe
I think
let's
the
do.
revenue is just that, from what I see, it's the consumer surplus and the producer surplus from the tax, just from that rectangle, the 21 to 27.
That's the tax.
That's the tax. Oh,
That's
no,
the tax. It's definitely not. That's definitely not revenue.
Okay.
But revenue is price times quantity.
Price is fine. Okay.
So that's why I think it's 21 times 15.
Okay. I think that's correct.
All right. Well, this is a good place for us to stop. Thanks again for scheduling, Jack, and I'll send these notes out and screen recording out shortly.
I appreciate your time, Matthew. Thank you
You're
very
welcome.
much.
Have a good day. Bye now.